Hello everyone, welcome back. This is Carlos again. So today we're going to talk about protocol parameters and configuration files. So I think this is a very important topic. If you are working on Cardano, if you are planning to do anything in Cardano, if you're developing for Cardano, if you want to run a stake pool, if you want to create a decentralized application, knowing the protocol parameters is a very good help. So by the end of this video, I hope that we all have a better understanding of the protocol parameters, the configuration files, how they relate to each other, and of course, hopefully this will trigger some additional curiosity so that you can go and have additional research, additional readings, and yeah, well, let's go just right into it. So I have switched my terminals and my presentation here. We should consider this like my slides in this workshop, tutorials or whatever. So I have moved my terminal here, and the first thing I want to do if I want to talk about the protocol parameters is actually query the protocol parameters. A mainnet node running over here, so basically it should be yeah, there's a node running over there. So what I want is to query the protocol parameters, and so we have Cardano CLI query, and we have this subcommand that is protocol parameters, and it says gets the node current protocol parameters. So that's great because that's exactly what we want, get protocol parameters. And let's see what options we have, and it will ask for mainnet or testnet magic, and we can specify an out file. So we don't need to use any of these options right now. So let me just basically go for the mainnet output. And as you can see, this is just a JSON format. The output is JSON formatted, and it contains like a mapping of all the protocol parameters. As you can see, this is a very long output, but most of it is taken by the cost models. So we have Plutus script v1, the version 1 of Plutus cost model, and the cost model for Plutus script version 2. We will see in a minute what it is about. But for now, let me just come here. I have just copied this output and put it here in the slides or in the presentation here. And I have collapsed these two cost models because we are not going to get into the details of the cost models. We're just going to get into the surface of what they are and why they are important and what they are used for. But we don't want to go into the details of the cost model right now. So for that, I'm just going to collapse it so that we can then have like all the output, all the rest of the output in one single shot. One thing that you might notice is that it is ordered in alphabetical order. So this is perhaps not the best way for me to have them right now, because some of those parameters are closely related to each other, and I would like to discuss it like close to each other. So I will reorder them later so that I have like a more logical order. But before we go into that, just keep in mind that the Cardano query command, the Cardano CLI query command, it actually queries the current values of these parameters. So it is querying the ledger state and retrieving these active parameters from the ledger state. So it is exactly the parameters that are active at the moment of the query. And apart from that, let me just say that apart from the protocol parameters, we have another set of parameters. We could say that they are also protocol parameters, but they are known as global constants. And the difference is like ones are really a little bit harder to update than the other ones. So the protocol parameters, one can really update them relatively easy. There is a method that Cardano has in place to update the protocol parameters, and it is via the Genesis delegate keys. So what it is? Well, remember that at the beginning, in the Byron era, Cardano started as a federated system. This federation was composed of Cardano Foundation, IOHK, and Emurgo. So these three entities were the only ones responsible for producing blocks, but also for the governance of the system. And governing the system means having the power to basically tweak or change or update these parameters. When we went to Shelley, we decentralized the block production. We distributed the block production responsibility so that these three entities are no longer responsible for producing blocks for the Cardano blockchain, but they are still responsible for the governance of the system. So, and that will be the case until the Voltaire era is basically released. So updating these parameters can be relatively easy, but it can only be done by either, basically by a number of these participants, and we will see in a minute how it works. But these entities are the only ones that have the power to propose a change on the parameters, and are the only ones that have the power to vote on an update of the parameters. So, but it can be done relatively easy. However, for updating the global constants, that's another story. It can be done for some of them, but it actually requires a update in the software, and it will require either a soft fork or a hard fork to update any of these parameters, which some of them are not really updatable, but in principle, this is how it works. It is way harder to update because it requires an update in the software. But let me just move on a little bit down here, where I have a table where I have tried to sort it in a different way, ordered in a different way, the global constants and the protocol parameters, different to the output that we have here. And the idea is that I want to discuss them in a kind of a more logical way to me. And the first one to mention is probably the network ID parameter. It's a global constant, and it basically determines what network we are talking about. Can be a mainnet or it can be a testnet. If it is a testnet, then we will have another parameter or another option to specify which testnets in particular, and that is the network magic. But for now, it is just the network ID, what identifies what kind of network we are connected to. And we can just very quickly do a cat for the Shelley Genesis file, and we will see that the network ID is showing up here, and it says, as expected, it says mainnet because I am connected to mainnet. So that is the network ID. The next one is another one that is kind of simple to understand. It is the max Lovala supply, and this is the maximum amount of Lovalas, or ADA, but expressed in Lovalas, that the system will ever have. And it is set to 45 billion in mainnet, 45 billion ADA, or 45 trillion. Yeah, it should be 45 trillion Lovalas. So, no, quadrillion, sorry, because, yeah, in English it is, yeah, it should be quadrillion, I guess. Quadrillion Lovalas. So, yeah, but 45 billion ADA, definitely. So, the idea is that the system will never have more ADA than that. And it's already there. All of them already exist, all of these Lovalas. Some of them are in UTXOs, more or less 35 billion ADA are already distributed across millions of UTXOs, or at least hundreds of thousands of UTXOs. And the difference between those roughly 35 billion that are circulating and the 45 billion that is the maximum supply is most of it is either on the reserves or the treasury. There is some, of course, in a reward pot, but this is what completes the total number of Lovalas in the system. Then we have K. This is one of the favorite parameters, let's say, because it is very powerful, and it is known as the security parameter. And it basically tells us after how many blocks a block or a transaction inside a block has become stable, so that we are certain that it will not be rolled back. Another way to say it is that it is like this parameter tells us how long a fork at the tip of the chain can be. And remember that the tip of the blockchain is always a little bit fuzzy. It can be changing a little bit. It allows for forks at the tip. But the longest a fork can be at the tip of the chain is 2,160 blocks. The next parameter we have is the active slot coefficient, and this represents the fraction of slots that will contain a block. This is an average. This is the value F from the Ouroboros Praus paper, and it is set to 5%. What it is about? Well, the active slot coefficient, remember that in Byronetta we had a block in every slot, and slots were 20 seconds long. So we had like 21,600 blocks on average per epoch. So now, if we move to Shelley, we have shorter slots. In Shelley, slots last 1 second, so we have more slots per epoch. So that means that if we want to have the same number of blocks per epoch, then we have to change the strategy. Just a fraction of the slots must have a block in it, so that at the end of the epoch we end up with more or less the same number of blocks. And the magic number here is 5%, because if we have epochs last the same, it is 5 days. So now we have more slots. It is 432,000 slots. That is 432,000 seconds. So if we do the math here, if only 5% of those slots contain a block, we end up with 21,600 blocks per epoch on average. And the reason for having this active slot coefficient is to allow for blocks to be propagated appropriately across the network, and this will promote stability, and it will prevent having rollbacks and this kind of stuff, right? So now the next parameter we have slots per epoch. So we have briefly talked about it. Is the total number of slots in an epoch. Right now it is 432,000 slots per epoch, and that is roughly, exactly 5 days. Then we have the slot length. As we said before, it is 1 second. We have, since Shelley, we have 1 second slots. Now we have the quorum. So we have briefly discussed a little bit about update proposals and the update mechanism for the protocol parameters. So this is very important parameter for that matter, because for an update proposal to be adopted, a minimum number of Genesis delegate keys must vote for that proposal, must support that proposal, and that is the quorum. And it is currently set to 5. That means that 5 out of the 7 Genesis delegate keys must agree on an update proposal for it to be adopted. Now we have the protocol version, and this is another very important one, because it serves a very interesting purpose later. The protocol version is constructed of 2 numbers, the major and the minor. This mechanism provides us a tool with the next parameter, which is max major, to actually enforce that. So we can enforce the max major version in the system. That means that when there is a new version of the node that implements new features, like recently in the Vassal hardware, we implemented some of the most interesting features that we have added, and it has to do with reference scripts, reference inputs, and all of that. So once we release this thing and we go to that version, which is the current version, which is 7.0, that means that previous nodes running version 6.0 were no longer capable of synchronizing the chain. So those nodes halted, and that brings us a mechanism to prevent real forks in the chain that can be competing. Imagine the scenario where half of the stake pools update to version 7.0 and half of the stake pools remain on version 6.0 and they continue to grow their own chains. So then it will be extremely complicated to figure out what chain should you follow, because if the stake is split in two, if it's split in half, it is really hard to follow, to think about which is the good one. And of course, one could argue that the one that is using the latest version, but why? So this mechanism actually provides a way for those guys running the old version of the node to receive just a warning saying that, okay, once they reach to the point of the hard fork, they cannot continue synchronizing the chain, and their nodes just halt, and they are just receiving a obsolete node failure, while all the nodes that are running a node that understand the latest protocol version, they can continue happily growing the chain